Good morning to all. Welcome to our course on the data structures. In this session, I am going to discuss about a sorting algorithm called as the quicksort algorithm. Let us see some of the properties of this quicksort. This quicksort is the most widely used sorting algorithm than any other sorting algorithm methods. So, if somebody asks you what is the fastest sorting algorithm, you can give an answer that the fastest sorting algorithm is quicksort. But this is not true in all the cases. As I told that we have different number of sorting algorithms like the bubble sort, selection sort, insertion sort, med sort, quicksort, etc. All the algorithms, sorting algorithms, they have their own pros and cons. For example, if you take the bubble sort algorithm, the advantage of bubble sort algorithm is it is very simple to implement, it is very simple to understand, but the disadvantage is it will work only for a limited number of elements. Similarly, if you go for the insertion sort, in the previous sessions also we have discussed that the insertion sort is efficient when compared to that of the selection sort and bubble sort. And it is efficient when we have almost sorted list of elements. Similarly, if you take the quicksort algorithm, it is the quickest algorithm by the name itself, but it works well for the large set of elements. When we have a smaller set of elements, you can go for the basic sorting algorithms like the bubble sort, selection sort and the insertion sort. But when the list of elements increases, then it is better that you go for some complex sorting algorithms like the quicksort or the med sort. So, people will say that the fastest sorting algorithm is the quicksort. The answer is correct, but remember that it is not in all the cases. You should remember the conditions where the quicksort performs well. And the second characteristic of this quicksort is it is not difficult to implement. You can either implement with the recursion technique or you can implement it with the iteration technique also. The program looks somewhat complex, but once you know the concept, implementation of quicksort is the simplest thing you can do it. And another characteristic is it works well with a variety of data. So, till now we have seen that the sorting algorithms work on the integer data. So, you will be taking an array of integers and you will be implementing the sorting algorithm on those integers. But the advantage with this quicksort is you can also implement this quicksort on the array of characters also. So, you can implement this quicksort on the strings as well as the array of integers, etc. And another advantage we have with this quicksort is it consumes fewer resources than other sorts in all the situations. Resources in the sense we are not going to consider other resources. The only resources that the algorithm or any program is going to consume is the time, and the second one is the space. The quicksort algorithm makes efficient use of the space that is available in the system, as well as it has the very good time complexity when compared to that of the basic sorting algorithms like the bubble sort, selection sort and insertion sort. We have seen the analysis part of the selection sort or quick sort or bubble sort. In almost in all the cases, we have the worst case complexity as big O of n square. But here if you observe the time complexity of the quick sort, it is around big O of n log n, where n stands for the number of elements. For example, if you take the n value as 8, that means the number of elements is 8. In the remaining sorting algorithm, the complexity will be around 64, 8 square, that is. But here in this case, you will come across, that is big O of n log n means 8 multiplied with log 8. So, it will be around 24 like that. So, this is the advantage we get from the quicksort algorithm. That is, it takes very less time, that means it executes very faster, and that is the reason why we call this algorithm as the quicksort algorithm. And coming to big O of log n, this is called the space complexity. So, we require some additional space to implement this quicksort algorithm, and that additional space we call it as the space complexity, and it is equal to big O of log n. By looking at these particular characteristics or advantages and the time complexity of the quicksort algorithm, let us move our discussion towards one important concept with respect to the quicksort, that is pivot element. So, the quicksort algorithm, it entirely, this is the name of an element. So, you will be given a list of elements as the input, and you are asked to implement the quicksort algorithm on that particular list of elements. The end result should be the sorted list of elements. So, the input is unsorted array, let me write it here, input is unsorted array and the output is sorted array. But one of the most important point, you should be very careful in this quicksort algorithm and you should concentrate on that particular concept, is the pivot element. Out of the list of unsorted elements, out of all the unsorted list of elements, we need to consider one particular element, or we need to designate one particular element as a specially designated element, which is called as the pivot element. And the selection of pivot element, we have different methods of selecting the pivot element. We will discuss it once we go through these slides, right. So, the selection of pivot element, we have different number of strategies, and the selection of pivot element plays very important role, and it has a very good role in improving the efficiency of the quicksort. So, the entire efficiency of the quicksort depends upon the selection of pivot element. Once you select a good pivot element, I will tell you what is pivot element, what is the purpose of this pivot element, all these things I will discuss. But once you select a good pivot element, you will have an efficient quicksort algorithm. This is what the pivot element is. What a pivot element is? It is one of the very important concept in the quicksort algorithm, and pivot element is a specially designated element in the entire unsorted list of elements. This is what a pivot is. Now, let us see why do we require this pivot. Why we require this pivot is, when you select a particular element as the pivot element and you do some operations that is related to the quicksort on the unsorted list of elements, at one point of time the pivot element will be placed in a correct position. So, during implementation of the quicksort, the pivot element will be placed at a correct position. Once the pivot sits at its correct position, then you can observe that the elements towards the left hand side of the pivot will be less than the pivot, and all the elements towards the right hand side of the pivot will be greater than the pivot element. So, the purpose of the pivot is it makes the unsorted list of array into two almost equal halves. We can simply say that it divides, the pivot element divides the unsorted array into two parts, where the left part consists of the elements which are less than the pivot and the right part consists of elements which are greater than the pivot. This is why we need this pivot. And once we have the pivot element, let me show this here. If this is the pivot element, all the elements towards this left hand side will be less, and all the elements towards this right hand side are more. This is less and this is more. Right. And after placing the pivot element in the correct position, the array is divided into two subarrays. One is the left subarray and the second one is the right subarray. And you have to implement the quicksort on the left subarray and the quicksort on the right subarray independently. And this process of applying the quicksort on the subarrays will be done until all the elements in the given list are sorted. So, if you observe this, the strategy that is behind this quicksort algorithm is, first of all, it is going to divide the things into equal parts, and then you implement the same strategy, that is the quicksort algorithm, on both the subarrays independently. You get the solutions for the smaller problems, and then you combine the solutions of the smaller problems to get the solution for the larger problem. This is what the strategy is, and this strategy we call it as the algorithmic strategy. The algorithmic strategy that lies behind this quicksort algorithm is divide and conquer. This is very important concept. You might be asked a question like, what is the strategy that lies behind this quicksort algorithm? You can simply say that it is divide and conquer. What is this divide and conquer? Actually, this is an ancient Roman political strategy. It is a Roman political strategy, which is very famous political strategy that is even implemented in today's political scenarios also. So, whenever some problem arises, what the leaders or the political people will do is, they will divide the group of people into smaller pieces, and they will try to conquer those smaller pieces, and ultimately they will get the conqueror of the entire group of people. For example, let me say that there are 100 people who are rebellious to some organization. So, what these admin people will do is they cannot conquer these 100 people, or they cannot control these 100 people as a group. For this purpose, they will divide these people into two based upon some casteism or racism, whatever it may be. So, they will identify some people who are who can easily change their mind based upon some caste equations or religious equations, whatever it may be. They will identify those people and they will divide the group into some smaller parts, like 25 people in one group, 50 people in one group, and again 25 people in one group, like that. This is for an example I am taking. So, the entire 100 people is divided into 3 groups, and these admin people, what they will do is they try to conquer this 25. That means, they will say they will call these 25 people and they will say that they will give some benefits to these 25 people only. So, these people, what they will do is they will simply suppress their ideas and they surrender to the admin people. Similarly, they call this 50 people group separately and they will say that we will be giving so many benefits to you irrespective of the other 2 groups. So, they will suppress their ideas, rebellious ideas, and they will surrender to the admin people. Similarly, they implement the same strategy or different strategy maybe, but in this case they need to implement the same strategy, and these people also get admitted to whatever things the admin people has told here. So, they have conquered this smaller group, they have conquered this group 2 also, they have conquered this group 3 also. Ultimately, the result is they have conquered the entire 100 people. This is the Roman political strategy, ancient Roman political strategy, but it is a very famous political strategy even for today also. Even if you might have studied the school textbooks somewhere in the British rule, they used to say that British used to implement the political strategy which is called as divide and conquer. So, what they will do is whatever largest problem we have, they will divide it into smaller pieces and they try to find the solution for the smaller pieces like this, and finally, they will combine the solution for all these smaller pieces to get the solution for the larger piece. But the mathematics scientists, they found that this political strategy is very efficient, and they found that it will be very beneficial if we implement this divide and conquer strategy in our problems or in solving our mathematical problems. So, they have inherited this political strategy divide and conquer to get the solutions for the mathematical problems also. And we know that the computer science, the base for the computer science is mathematics only. So, in olden days, at the time of starting this computer era, most of the algorithms or most of the things that were developed will be from the mathematicians only, famous mathematicians. So, from mathematics, the computers has inherited this property, and they have applied this property or the strategy of divide and conquer to almost all the complex solutions or almost all the complex problems to get the easier solutions. So, remember that the entire strategy or the algorithmic strategy that is used to implement the quicksort algorithm is the divide and conquer strategy. Very important thing. And coming back to our discussion on pivot, we have discussed what a pivot is. A pivot is nothing but a specially designated element in the unsorted list of elements. Why we require this pivot? This is also we have discussed. Why we require this pivot means the pivot element divides the given list of elements into 2 almost equal halves Thereby, you can apply the quicksort algorithm on the sub arrays separately recursively, and the method that we are going to use for applying the quicksort on the sub arrays is the recursion. Recursively, you will apply it on the sub arrays, and again they will divide it into two sub arrays. For example, the left part is again divided into left sub array and right sub array. Similarly, the right sub array is divided into left sub array and right sub array. Again apply the quicksort on this part, another quicksort on this part, again quicksort on this part, like this. This particular strategy of applying the quicksort on the smaller units of the problem should be continued until you get a sorted list of elements. And remember that the pivot element selection makes a very important role in the improvement of the efficiency of the quicksort algorithm. When you select a best pivot element, see here, what is a best pivot element and what is a worst pivot element. I told that the pivot element is to break or is to divide the given list of elements into two almost equal parts. For example, if I have 11 elements in the unsorted array, if I select the pivot element as one element and after making some implementation of the quicksort, my pivot has occupied this position, it is its correct position. So, the left part will have the lesser elements and the right part will have the greater elements. This we know very well. Assume a case 1, where the left side subarray consists of 5 elements and the right subarray consists of 5 elements. So, total 11 elements are divided into one pivot, 5 elements towards its left subarray and 5 elements towards its right subarray. Here the pivot is dividing the list of elements into two equal parts. So, this is considered as the best case, that means whatever pivot you have selected, that is the best pivot element. And let me take another case where I have the same 11 elements, this is my pivot and I have left subarray and right subarray like this. So, in the left subarray, let us assume that I have 3 elements and in the right subarray I have 7 elements. This is case 2. So, I have less elements in the left hand side, but more elements on the right hand side. This is considered to be an average case, that means whatever pivot you have selected, it is dividing the given list of elements not equally, but almost equally. And let us take the last case where I have the pivot element, I have 11 elements in total and one pivot element is there here, and let us assume that towards its right hand side I have 10 elements, but there are no elements in the left hand side. This case we are going to consider it as the worst case. That means, the pivot, the main role of the pivot is to divide the list into two almost equal parts. Either it can do this one, which is the best case, 2 equal parts, or either it can do like this, which is a almost equal parts. But here in this case, the pivot is dividing the given list of elements into 2 unequal parts. Almost the left part is nil and the right part is full. We can take the other case also. The pivot will be sitting at this position and we have all the elements towards its left, but there are no right elements. This is also considered to be a worst case. That means, whatever pivot you are going to take, it is going to sit in a position where one part is having the remaining elements and the other part is having 0 elements. So, this is not equally distributed. The main role of pivot is to divide the given list of elements into 2 almost equal parts, but this is not happening here. If this is the case, you cannot apply quicksort on the left subarray, but whatever you are going to apply, everything you are going to apply on the right subarray only. If this is the case, you are going to apply the quicksort entirely on the left subarray, but no quicksort implementation on the right subarray. So, these two cases are considered to be the worst case scenarios. In this case 3, that is the worst case, the performance of the quicksort algorithm or the efficiency of the quicksort algorithm will be reduced. So, you will have the best performance of the quicksort algorithm in case 1 or case 2. That means, if the pivot divides the given list of unsorted list of elements into 2 equal parts or 2 almost equal parts. This is all about the pivot element. We have seen what a pivot is, we have seen why this pivot is, we have seen the algorithmic strategy that lies behind this quicksort algorithm, what is called as divide and conquer, and we have seen 3 different cases of how this pivot selection will influence the efficiency of the algorithm. Next, we will discuss the strategies that are used to select the pivot element. Different strategies are there to select the pivot element. As we told that the selection of pivot plays important role in finding the efficiency of the algorithm. It may run very fast or it may run in the quadratic time. That all depends on the selection of the pivot. Some of the strategies that are used to implement the pivot element is, the first one is you can take some fixed element. That means, you can take the first element as the pivot, or you can take the middle element of the unsorted list as the pivot, or you can take the last element as the pivot. Any of the fixed element you can take, but this will be a very bad choice. When I say bad choice, means the pivot is going to end up in one part of the array. Either it will move to the left end where we have only right subarray, we do not have any elements towards the left hand side, or the pivot will move towards the right end where we have only left elements and no right elements. So, taking some fixed element like the first, last or the middle element will make the pivot as a poor selection. And the second strategy for selecting the pivot element is the randomly chosen element. The randomly chosen element can be taken as a random element from the list of elements. That means, you are not fixing anything. You can have the first element, you can have the second element, you can have the third element, or you can have the fifth element. Any of the choice you can take, nothing wrong in it. And the third, but still this is a bad choice. You may end up in having a pivot which is dividing the list into unequal parts. And the third strategy is very important one, the median of the array, but this takes very large time. Before this before discussing about the median of the array, let us discuss the median of 3 choice. So, how do you calculate the median of 3 numbers? Means, you have to arrange those 3 numbers in the ascending order, and whatever element that is present in the middle will be the median of those 3 elements. So, what are those 3 elements? You take the first element of the unsorted list, the last element of the unsorted list, and the middle element of the unsorted list, and you arrange them in the ascending order. Whatever element that comes in the middle of these 3 elements, that is considered to be the median. The same is the case with median of the array. Array is nothing but the list of elements. When you have a list of elements, To find the pivot element, you have to arrange all the elements in the sorted order, and then you have to find the middle element, which is a very excessive work you have to do. So, where it increases the complexity. Why? Because you are going to implement the quicksort, which is going to sort the unsorted list of elements, but for that we require a pivot element. For selecting the pivot, you are again arranging all the elements from the list in the sorted order, which is a very useless thing you can do. So, this is a ultimately bad choice. This is also a bad choice, this is also a bad choice, but this comes to somewhat a good strategy that even now everybody is going to follow, but this is not a thumb rule that you should always follow the median of 3 choice. If you are feeling comfortable that the last element is the largest is to be taken as the pivot, you can go for it, nothing wrong in it. Or if you feel that the middle element is good, then you can go for the middle element also, nothing wrong in it. Let me take an example here. So, the median of 3 elements, like for example, consider this as the first element and consider this as the middle element and you consider this as the last element. To find the median of these 3 elements, you have to arrange these 3 elements in the increasing order, that is 3 followed by 5 followed by 12, and the middle element you have here is the 5. Therefore, the median of 12, 3 and 5 will be 5. This is how you calculate the median, very simple technique. And coming to the median of an array of elements. So, these are the list of elements you have 3, 13, 7, 5, 21, 23, 39, 33 like this, and this is an odd numbered list. When you arrange these, when you want to find the median of this odd numbered list of array, you have to arrange these elements in the ascending order and you find the middle element, and that is considered as the median. Similarly, you can find the median of even number list also. You arrange the list in ascending order and you take the middle element. Since it is even numbered, you cannot have the middle element. Middle element means you will have 2 elements. For example, 1, 2, 3, 4, 5, 6. This is an even list which are arranged in the ascending order. If you want to find the middle element, there is no middle element here. These 3 and 4 are considered to be the middle element. So, either you can go for the left hand side element as the median, or you can go for the right hand side of the list. If you go for the left hand side element, we say that it is left biased median, since you are biasing towards the left side. And if you select the right element as the median, it is called as the right biased median. And once you fix with this right biased or left biased median, you have the same starting the remaining quicksort implementation also. So, you will be implementing the quicksort on the left sub array, left sub array, all these things. In all the cases, you have to implement this left biased only. The thing is that you cannot go for left biased in one case and you cannot go for right biased in other case, right. For example, let me take this 1, 2, 3, 4, 5, 6, the same thing. If I implement the left biased thing, 3 will be selected like this, and if you go for the left sub array and again we have the right sub array, assume that I got the 2 elements as the middle element. That means, the left sub array is even numbered and the right sub array is also even numbered. In such case, since in the initial stage you have taken the median as the left biased, in this case also you have to go for the left biased only. Similarly, in this case also you have to go for the left biased only. So, this is what you have to follow. Once you take one particular strategy, left biased median, you have to follow that left biased median in all the sub cases, or once you take the right biased median, you have to follow the same thing in all the cases. This is what the median is. So, this is all about the introduction part regarding the quicksort. We have seen, let me have a quick recap of what this quicksort, what we have discussed under this quicksort. The first topic what we have discussed is the characteristics of quicksort, where we have discussed the most widely used thing, not difficult to implement, works well with wide variety of data. And then we have gone through the time complexity and the space complexity, where the time complexity is big O of n log n and the space complexity is big O of log n. And then we have moved our discussion towards the pivot element. We have seen what a pivot element is, we have seen why we require this pivot element, and we have already gone through the algorithmic strategy that lies behind this quicksort algorithm, which is nothing but the divide and conquer strategy. And similarly, we have seen what is a best pivot, what is a worst pivot, and then we have seen the different strategies that are used to implement the pivot or to find the pivot with few examples. That is all for the introductory concepts related to the quicksort algorithm. Thank you one and all for joining the session. In the next session, we are going to discuss about the algorithm for the quicksorting, and we will also discuss the quicksort algorithm with one example. We will trace the quicksort algorithm with a list of unsorted elements. So, that is all. Thank you one and all. Thank you.